as well. What do you think? Like, do you think this is the right way to find dark matter? Like, just waiting for something to interact, or do you think there's a more, out there approach that we can do to find it?
Right, okay, right. So the first thing I'm going to say to that is that, okay, Super CDMS is not a giant tank of something.
Okay, sorry.
And
Yeah, maybe you want
part
to
of the
explain what
reason
that
for
is first. Yeah.
that is that in order to build more and more sensitive things in the style of these noble element searches, it involves making bigger and bigger tanks of stuff. Which means you then got to, purify all the extra stuff that you're putting in, and you've got to, build more and more support structures out of more and more materials, which have to be extra purified, and then you need more and more of whatever detection apparatus you're using, and more electronics readout, and so on. So basically, what I'm saying is that I don't think giant tank of whatever projects are particularly scalable in terms of making them more and more sensitive. So that's why the kind of experiment that I work on actually tries to take advantage of quantum sensors. And so Super CDMS, which is short for cryogenic dark matter search, uses semiconductor crystals, which are only like this big each, and you can stack several of them in a tower that a person can stand next to and reach around. And they basically, instead of waiting for a dark matter particle to come into the giant tank, they wait for a dark matter particle to interact with the crystal lattice and set it vibrating. And there, we now have the capability to detect single electron hole pairs that are produced. And we can translate just a very small number of phonons, where phonons are quanta of vibrations in a crystal lattice, um, into a signal that we read out using these things called transition edge sensors and superconducting quantum interference devices. And these squids, as we call them, superconducting quantum interference devices, are
Nice
actually
acronyms for sure.
the same things that some people are trying to use to build quantum computers. And the idea is that these quantum sensors are basically far more sensitive than any other such device we've ever constructed. And so my idea is to look to the very small scale and look to these quantum devices to get us better and better sensitivity to more and more feeble interactions. Um, and then I've also sort of come to the conclusion that looking for things in a very, very quiet, low background environment deep underground is better than trying to pick out a dark matter signature or a dark matter signal from this very noisy zoo environment of high energy particle collisions that happen like in Large Hadron Collider. Because even if you do produce the dark matter particles, you have to pick out their signature from amongst, all of the other debris that went off in that extremely energetic collision. And when you've got just all this other stuff going on with, Higgs bosons decaying and radioactive stuff and, extremely high energy muons and gammas and all sorts of other things. And you have top quarks and bottom quarks, which are decaying into other quarks, which then decay into other quarks. And then you have neutrinos running all over the place, which also go straight through the detectors. And so even if you have, a missing energy signature, you then have to figure out, okay, well, was that just from the neutrinos? Because you've got neutrinos running around all over. And you have these events that are happening like every few tens of nanoseconds. And then in each of these events, you have actually bunches of protons which are colliding with each other, not individual ones. So you have what's called pile up of like potentially dozens of collisions happening at exactly the same time, pretty much. And then you've got to reconstruct the debris from all of those collisions and try to pick out, the very, very, very rare dark matter signatures. I just, I'm not going to say that it's hopeless, but I think that it's extremely challenging.
Sounds very
So
hard. Sounds like a lot of
that's
work. I mean,
basically
obviously, we're not
my
even.
pitch for
Yeah.
why I do the type of experiment that I do. So I think that basically quantum sensors in a very quiet, very low background environment underground is the most scalable way to go, and it gives us the best chance of actually picking out the dark matter interactions.
So you do believe this underground sensor is the way to continue to search for dark
I
matter?
do, I do. Of course, I may be
Nice.
proven completely wrong when some other completely
Well,
different type of
let's
dark
see,
matter
right?
search
That's
finds it, and yeah. So I mean, I am always, how can I put it? I try to have a lot of humility when I say that, because nature tends to surprise us, and nature doesn't care what I think.